Hey everyone, welcome to Zoom 326 or March 26th, the Thursday. Couldn't be with us for Zoom, or if you just need to re-see some of these parts, I wanted to welcome you guys. So the first thing I did was I jumped on to activity 323. This assignment, I want to start with the quote because I often don't read these quotes even though they're on there, but I think this one's really important. If I am given a formula and I am ignorant of its meaning, it cannot teach me anything. But if I already know it, what does the formula teach me? And so the reason why I really love that quote is because it really goes back to the foundation of why I wanted you to learn the static equilibrium equations, or to reiterate the importance of the static equilibrium equations. Because if you understand the static equilibrium equations, you can actually solve for the reaction forces and inherently the shear and bending moment diagrams for any problem. It doesn't have to be one of those 6 scenarios. It's really kind of interesting that you have these 6 scenarios you're given, because in real life there's so many different scenarios that could happen. There's so many unknowns. It's not going to fit into one of these molds. But what I wanted to do today was to introduce you to the shortcut formulas, which some of you may have referenced. I'm also going to show you how inherently you could have checked your answers using technology, and we're either going to use MD Solids or SkySieve for the time being. But why don't we jump right into it? So this directly correlates and connects to 322. This assignment asks you to do the following. It asks you to relook at exactly those 6 scenarios that we had. A single point load in the center, a distributed load, a combination of both, 2-point loads that are symmetric to each other, similar situation with 5, and then 6. We've seen these problems before. These are now reintroducing us into the problems, right? So what I ask you to do is to copy and paste calculations, the shortcut formulas for scenario 1 through 6 using formula shortcuts. I also want you to use MD Solids or SkySieve in order to create a shear and bending moment diagram, just like the one you did in 322, but this time using technology. So why don't we look at the reaction, or sorry, why don't we look at what the problem is? Well, I asked you in the last assignment to go ahead and use static equilibrium equations. The sum of the moments about a point is equal to 0. The sum of the forces in the y direction is equal to 0. The sum of the forces in the x direction is equal to 0. And that takes a little bit of time, right? You have to, go through the problem. You have to solve it. You have to, draw your diagram. You have to solve for the area underneath the curve for the shear. Going back to your question, Alejandra, you asked me, how do you solve for the max moment? Well, you just solve for the area underneath the curve. But what if I told you there was a shortcut for doing it, right? So one of the things that we're going to see is there is actually, the shortcut is this. If you have a center point load, let's say P is equal to 500 pounds, what do you inherently know the reaction force is going to be? 250, 250. Now someone could have said, well, that doesn't seem that, I didn't need a formula to tell me that. I just figured that out myself. Well, same thing here. We can plug and chug now. Now that we understand the concept, it's okay to go ahead and use shortcuts. If I have a distributed load across a beam, the formula is W, which is the value of the load. So W would be 100 pounds per foot times L, the length of the beam, divided by 2. If I have this scenario, I can use this formula. I have this scenario, I can use this formula, right? So not only that, the shortcut formulas also tell me that I can determine the max moment through a plug and chug. So I want to make sure that for each of these formulas, you understand what each variable is. E is the magnitude of a point. L is the length of the beam. W is the magnitude of the distributed load, which will be in pounds per foot. Let me see if there's any other variables here. A is the distance from a reaction force to the point load. And I think that's all we have to deal with. As we start getting into deflections, I'm going to talk about that in the next assignment, but we will use these formulas. Just realize that there may be some things that you're unfamiliar with, like E, which is modulus of elasticity, or Young's modulus, or, there's a lot of ways to say it. I is moment of inertia. If you took POE, hopefully this is something that you're familiar with, but I'll go over it in the next assignment. But what's the goal of this assignment? Well, literally, you're just going to plug and chug and get the same exact answers you got in assignment 322. Yeah, you're going to do it all over again. Why? This is our answer key. What we're going to do is we're going to use these shortcuts to prove, or, oppositely wise, prove that we were wrong on 322, but hopefully prove that we were right on 322. Now, it doesn't mean you still can't do calculation problems. I've given students the formula and just said plug and chug, and I come back and yeah, it's not right. So what's another check, right? As engineers, we want to do a 3-point check. We want to use every single tool we have accessible to us. And it'd be crazy to imagine that we don't use technology as one of those tools, right? We are lucky enough to live in a world of technology. So one of the things I wanted to do was to introduce you to 2 softwares that we can use. One of them is MD Solids. Now, I am actually going to interrupt this presentation to ask at least the folks that are on right now, have any of you had any luck downloading MD Solids?
Yeah, down in like 30 seconds.
Okay, good. And have you opened it up, Elio, and had a chance to interact with it?
Yeah, I've gone through like every single one of those tabs there, and they all work.
Perfect. Okay, so if you have, thank you, Elio. So if you have a computer that allows you to download, right? Chromebooks, don't download software to it. But if you do have a computer that allows you to download to it, one of the things I'm going to encourage you guys to do is MD Solids. It's actually superior in a lot of ways to the other website. The other website gives you limited accessibility, and it's a paid site. It does a lot. It does like a ton of stuff, but it's also a paid website. But the feature we're using is free, so I'll demo that. So what you're going to do is you're going to go to determinant beams. And what you're going to see is you're going to either have a simple beam, a cantilever beam that's left supported, or a cantilever beam that's right supported. We have a simple beam. Now, why don't we go ahead and do the problem from the very first problem, right? And now we can go ahead and check to see whether it works or not. So what I'm going to do is, oops, sorry, I accidentally closed it. What I'm going to do is to check whether my loading calculation was correct. So my beam was 16 feet in problem number 1. The location of left support was at 0. The location of the right support is at 16 feet. It doesn't have to be at each end, right? Supports could be more towards the center, and then the beam can cantilever on the edge. So don't take it for granted that, yeah, it's always 0 and 16. Our problems, they are, but in real life, a lot of times beams overhang on one end. I'm going to hit enter. From there, why don't we start with a simple scenario? I know the load location was right in the middle at 8 feet. I know the load magnitude was 500. I'm going to say enter. I could do distributed loads as well, or uniformly distributed loads, or ununiformly distributed loads, right? We call it linear load up or linear load down, right? Because as we move, across the beam, it doesn't have to be uniformly distributed. Maybe the materials get heavier as we move along for whatever reason. There it is. It's as simple as that. That was your answer for number 1 on assignment 322. It tells me the shear. And the end shears is equivalent to saying the reaction forces. It tells me what the max moment was. So what am I going to do? All I'm going to do is go like this, snip it, right click, copy, go to my assignment, scroll down, and then paste it on there, right? I'm going to go ahead and delete it since this is the copy for everyone. But we're going to go ahead and take pictures of 1 through 6. Now, if you have all 6 calculations on one page, that's absolutely fine. But what I want you to do when I say calculate is I want you to not only calculate the reaction forces, which is our end shear or our maximum shear, and also the max moment. All right, so I want you to calculate both of those. Leave out deflection for now. I'm going to circle back to this formula in 324, but we want to have it available to us. So the best suggestion I could give is these formulas are also located in your formula shortcuts, those 6 pages, or maybe 9 pages that you have in front of you in your notebook. So just realize that these are accessible to you, but these are actually a little more detailed. So there's actually, this is better than your formula sheets. So I would actually reference this document. Other than that, that's all this assignment is. It's really you're creating the answer key to 322. Now, some of you don't have computers that you could download MD Solids, and that's totally fine. That's accessible. So one of the things I did is I found this website, SkySafe. I've used it in the past, but let's say you want to change units. You change it here. Length, I want to change it to feet. All right, so let's first move into US customary. Now I'm going to add a beam. What was the length of the beam? It was 16 feet. I'm going to add supports. On the left support, which is at 0, I had a pin. And on the right support, I had a roller, which was at 16 feet. Then I'm going to add 1 point load, which was at 8 feet, and its magnitude was 500 pounds. I'm going to add it right towards the center. And then there's no distributed load, so I'm that one. Now I'm going to solve it. And there it is. There is my shear diagram. There is my bending moment diagram. It gives me the max moments, and it gives me information on it. And if I wanted to, I think I can even determine what it is at specific locations. I think if I type into, yeah, this is a paid website. Yeah, I haven't used this feature. I just saw it right now. But you'll notice that there's a lot of like paid features for SkySieve. It's actually a really cool site. It does very similarly to what MD Solids does, but you have to pay for it for an online version. All right. So other than that, I'm going to stop my lecture here. I said I'd only take about 15 minutes, and I'm right at that 15-minute mark. I want to open it up to Q&A. I'll start with Q&A related to 323. And then if you have questions on 322, feel free to ask me. However, to anyone that has not completed 322, realize I'm still expecting you to use static equilibrium equations, okay? So just making that very clear. You won't get credit for doing the shortcut formulas. All right, I'm going to open it up to questions. Q&A.
2 questions.
Yeah.
So for 323, you want us to take snippets, but also in our notebooks calculate with those formulas, or?
Yeah, you're exactly right. So
Okay.
there's almost 2 things you have to do in this assignment. The first half is to beam number 1, shortcut formulas, end reaction forces, max moment. Number 2, shear end reaction force, max moment. And then you're going to take a picture. You don't have to separate it 1, 2, 3, 4, 5, 6. Like you don't have to give me 6 pictures. If they're all on one page, just take a picture of 1 page of your notebook for all 6.
Okay.
Then you're going to do 6 individual snippets showing me that you've interacted with either MD Solids or SkySieve to create models on the computer.
Okay. And this is due when?
This is due next Wednesday, so you have plenty of time. I'll put it that way. This assignment, now don't, how can I put this? Don't hold off to Tuesday or Wednesday to do this, everyone. The fact that you're here.
Yeah.
Let me mute really quick. The fact that you're here tells me that you're probably not looking to hold off, but this is a fast assignment. You can work on it now. I'll be back online. And actually, one of the announcements that I'm going to make on this recorded video is that they're moving into, I guess you guys, I don't know if they've already told you, if any teacher has told you, but if you look at my screen, this is what they're going to start pushing in next week. Technically, I shouldn't even be sharing this with you, but we'll move on. If they haven't shared this with you, next week, we're moving into block scheduling where I can only give these lectures during my class period. So since you guys have me for 4th or 5th, it's so weird, but I'm going to have to do 1 Zoom on Wednesday between this time frame and then another one at 8:30 for this one. And I guess technically I'll just say you could show up for either. And then I have to do another Zoom here and then another one here. I don't love the format. It's kind of like a triangle, huh? Or like a pyramid. But I don't love the format, but this is what's going to come out. So just realize that you probably won't see me at the same time next week as you did before.
I do not like this.
Hey, you know, there's pros and cons. I think there's no perfect method, but
yeah, of course. Yeah.
Yeah. So other questions though? Any questions on the lecture itself? Questions on the lecture? 322 is graded. If you turned it in, it should be graded for you, unless you turned it in like now, which is possible. Sure. Okay. There are 2 people that turned it in now. So I will grade those but look at your comments. Please look at your comments. I take time writing your notes. Please read them. And then otherwise, anything else on 323 that you guys are trying to clarify? So anyone that came in late, I am recording this lecture. I will post it on YouTube and Google Classroom. It takes me about 10 minutes to do so though, because it's kind of a long process nowadays. It's just really slow to upload any video with all the server, capacity that they have, or lack of capacity. Anything else? Anything else? Anything on 322?
Mr. Menjivar, not on 322 or 323, but can we do one clap for Almost Friday?
Oh, yeah. That's right. That's right. Okay. All right. Gosh, you guys, I'm really terrible here. Okay. Anyone in the video willing to share? Anyone willing to share their screen, please come on in.
I'm here.
There we go. Brave soul. Do you guys do videos for your other classes? Do you guys actually have to show yourself?
Hey, how can I turn on my video?
There's a little camera thing.
Oh, I got it.
Okay. Here we go. Come on in, come on in. I got to start sharing Friday videos. I've been reaching.
Yeah.
I'm looking into this whole 3D printed math stuff. I'm definitely not taking advantage of my time being local. I 3D printed this little. Do any of you know Brown and Connie, the little brown bear, and it's the Line Friends character? Anyone know what I'm talking about? Line Friends? No. Okay. I'm making little cookie cutters. So I'm 3D printing that.
That's cool.
Okay. All right. No one else? Come on, folks.
I don't have a camera.
Excuse the Nacho Libre music in the background.
Brianna, I'm still expecting you to go ahead and do this, even if you don't.
I'm gonna clap. I'm gonna clap. Don't worry.
Okay. Okay. Good. Good. Ewan, make sure your audio is on. So
Okay, got it.
Okay. Okay. All right. Hands up, folks. Hands up. Hands up. Okay. 3, 2, 1. I love the delay. It sounds like there's some kind of delay. Okay. I should have probably stopped recording this already since.
Oh shit.